Now, questions on the homework. So, what we're talking about today is applying transformations. You do not have to write all of that. As long as we're doing especially just the straight paper notes, I will tell you exactly what we need, especially with the starting pieces. With this here, horizontal and vertical translation. The main thing we need for this here, horizontal translation's general form is f of x minus h. So when we apply a horizontal translation to a function, we're going to be using this notation f of x minus h. Vertical translation, the general form is f of x plus k. We're going to be using that form. So if I'm going to apply a horizontal translation, we're going to use f of x minus h. If we're doing vertical, it's going to be f of x plus k. F of x, g of x, k of x, L of x, n of x is just a way to name the function. It tells us what we're talking about, which equation we're talking about. So realistically, we could say f of x plus k, or we could say m of x plus k, we're applying it to m of x, or L of x plus k, we're applying it to that function. That's all function notation helps us do, is we know what function we're talking about. Questions on this so far? So at this point, I'm feeling, for the most part, they're just letters. We know that h kind of talks about our left-right movement, k is up and down. We have that, but how does this work in the context of applying a transformation? So let's actually see this. Now, for all of this here, the main things we need, one, we need to know what f of x is. F of x equals x plus 2. And we want a translation 3 units down. So those are the two main things we're going to want for this example. We need the function f of x equals 2x plus 1. And we want to translate it 3 units down. Now for our new function, we want to write a function g. So we're just going to call it g of x. But the name really doesn't matter. It's just a way that we can distinguish between the two. All it is a name. Questions on any of this so far? Now for this here, we're talking about a translation 3 units down. We're talking about a vertical translation. We're moving up or down. So the general form for vertical translation is f of x plus k. F of x plus k. Where k is the amount that we move the function up or down. No, someone was coming in or out. That's just the general form. How far are we moving the function up or down? 3. 3, so that's our value of k. So k would indeed be 3. Now, would it be positive 3 or negative 3? Negative because we're moving down. So we replace k with its value of negative 3. Question so far. Now, f of x. F of x is what? So we're going to replace f of x with what it equals. Because we still have f of x. We know that f of x is equal to 2x plus 1. We substitute it in. Now we need to simplify. Questions on how we got 2x plus 1 plus negative 3? So when we simplify, we need to look at the parentheses here. Is there a number in front of that parentheses for the 2x plus 1? Well, no. So that means we're not distributing. We don't have to multiply those parentheses through it at all. So it's just going to be 2x plus 1. We can just drop those parentheses. Really what we're doing is we're multiplying through by positive 1. But that's just 2x plus 1. Nothing changes. The second part we have is plus negative 3. Do we actually write plus negative 3? No, what's that the same as? Negative 3 minus 3, yes? So really what we have is this here, 2x plus 1 minus 3. And we could say we're done, this is the equation, as long as there are no like terms. Are 1 and negative 3 like terms? Yeah, 1 minus 3 is what? Negative 2. 2x and 2 are not like terms, so we can't combine them. So we've combined everything that we can combine. That's it. So our new function that we get from moving f of x down 3 is 2x minus 2. That's it. That's our new equation. Questions on this here? And what we'll see, especially with every single transformation, when we apply it, I would stick to these general forms, plugging in the information in these general forms, simplifying down, because they will help us do these transformations every single time. Also, just like with 1.2, I am not expecting y'all to memorize all those transformations. You can have them written down on your review sheet, notes, look back on them, reference them. For our second example, we're still using the function 2x plus 1. We're using it again. And also might be helpful to note in your notes, but this time we're translating it 2 units to the left. So it might be good to have the 2x plus 1, 2 units to the left. And this time they wanted us to call it h of x. F of x is still 2x plus 1. We're wanting to translate it 2 units to the left. What is the general form for horizontal translation, or left-right movement? F of x minus h, where h is going to be our movement, how far we're moving it to the left or to the right. So they told us we're moving 2 units. So we know for certain h is indeed going to be 2. Yes? Now the question is it going to be positive 2 or negative 2? Left is negative, yes? And we were talking about the other day, it's opposite of what we think, yes? Now, if we left it as just 2, we do have x minus 2. But if we're looking at it in context of yesterday, opposite would now be to the right, but we're not moving right, we're moving left. So we would actually put in negative 2, because left is negative 2. And a negative makes a positive. So it feels like, especially we do this for the first time, we look at it, well, you said it was the opposite of what we think. H is still negative because we're moving left. But after we plug it back in, we do get that plus, we get that opposite movement again. As we're going left, it gave us x plus 2. If we'd have gone right 2, h would have been positive 2. And after we plugged it in, we would have had x minus 2, that opposite look to it. Does that make sense? Question?
Why is it minus 8?
Because it's based off the overall function, because when we plug a number in left and right, it's always going to have this movement based off the numbers that we put into it. It's based off domain and range, really. And it works this way for pretty much all of them. Circles, x minus h squared plus y minus k squared. Ellipses, there's very few that we actually have plus number. Any other questions? All right. Now, for this one here, they told us f of x is equal to 2x plus 1, yes? What do we have at the moment? We have f of x plus 2. So we can't just rewrite this as it is, because it's not f of x anymore. It's f of x plus 2. What have we done? We've replaced this x with what? x plus 2, which means every x in the equation has to be replaced with x plus 2. So we would still have the 2, but instead of x, we have x plus 2 plus 1. This seems very new. Yes, having to do this. Y'all have actually done this before. Evaluate the given function f of x when x is 3. Because if we evaluated f of 3, we would have said 2 times 3 plus 1. We plug the number in and we solve. Y'all should have seen this, at least Algebra 1, 8th grade, this function notation, simplifying these here. Y'all have seen this a little bit in some form. But actually having an expression, we can do this with expressions. We're very used to numbers because number just we replace x with that number. We can replace it with the expression x plus 2. Works the exact same. We're doing the exact same thing. We're plugging that in for that value. We kind of see how that works. Last thing we have to do is simplify. We're going to distribute the 2. 2 times x is 2x. 2 times positive 2 plus 4 plus 1. Do we have any like terms? Yeah? 4 plus 1. So our function is 2x plus 5. Questions on this here? I think we need to see a few more of these, yes? Be nice to see a few more. We're good to move on to the next one. So on your note sheet, you do need to have f of x equals 4x minus 9. And the only other thing I would have is that we have translation 5 units up. I don't need so much of that, but 5 units up. Write a function g whose graph is a translation 5 units up of the graph of x. Vertical translation up and down. Standard form is f of x plus k. What would the value of k be? 5, because it told us 5 up, yes? Would the 5 be positive or negative? Positive, because we're going up. Negative if we were going down. We good about finding k, how we plug it in? Now the other part of it is our f of x, yes? It's still just f of x, unlike the last one where we had f of x plus 2. Already lost it. F of x plus 2. We just have f of x, yes? So it's still equal to what? 4x minus 9. We're just switching it. We're substituting it in. Because technically, we replaced every x in f of x with x. So it went from 4x to 4x. Nothing changed. It's just the same equation. Questions on how we got here? Yes, sir.
Why we put the parentheses on the bottom?
So I am always in the habit. So the question is why we put the parentheses around the 5. And that is, I would rather put them and not need them than need them and not put them. Because as we look at the 5 here, the sign in front of it's a plus, yes? So that and positive 5 is just going to give us plus 5. We don't necessarily need them there, but I would rather put them. I will always put more parentheses than needed. Whenever I substitute something in, I always put it in parentheses. Just to make sure our order of operations still hold true, especially in calculators, 30XS, graphing calculators. Always put parentheses, even if you don't necessarily need them. Because it will follow an order of operations, and if they're not there, it will throw the whole thing. It won't do it quite right. That's a good question. Any other questions? Do we need the parentheses around 4x minus 9? We can simplify it. There's nothing in front of it. So it's just going to be 4x minus 9. We simplify those. They drop, telling us that we have 4x minus 9 plus 5. Negative 9 and 5 are like terms. So negative 9 plus 5 is negative 4. Telling us that our new function g of x is 4x minus 4. Questions on how we translated this 5 units up? What would have happened if we translated it 9 units up? It'd just be 4x because we would have had negative 9 plus 9. Negative 9 plus 9 is 0. We just get 4x. There's nothing to say that the constant number, our number, can't simplify out completely. We will still have the variable. We're ready to look at the next one. All right. For the next problem, we still need the fact that f of x is equal to 4x minus 9. But this time we're translating it 1 unit to the right. And just like the last so many, they want us to call it h of x. Just another name for it. What is the general form for horizontal translation? F of x minus h. It tells us we're moving 1 unit, yes? Specifically 1 unit to the right. So would it be positive 1 or negative 1? Positive because we're going right, yes? So we plug positive 1 in, which gives us x minus 1. Flipping that sign. Questions on this here? Just like the last one where we moved left, right, we don't have f of x anymore. We have f of x minus 1, yes? So that means every x in f of x has to be switched to x minus 1. So we'll still have the 4, but instead of x, we have x minus 1 minus 9. Now, because we have just parentheses, we don't have squares, we can simplify this. We can easily multiply through by 4. 4 times x is 4x. 4 times negative 1 is negative 4. Negative 4 minus 9, negative 13. So our new function, h of x is 4x minus 13.
Teachers, pardon the interruption. Tomorrow during lunch, if you
Questions on how we got here? Feel good with this so far? And like I said at the start, the biggest thing with this here, any of these transformations, is coming back to these general forms. I always stick to these general forms because they give us a succinct way to actually apply each transformation and a ordered way to do it where I can plug the information I have in, know where it goes every single time, and it will tell me how to apply it. F of x equals 3x, semicolon. Translation 5 units up. That's as succinct as we can get it. We don't have to exclude anything on that one. We need everything from there. Now, if you notice, it did not tell us what to call this one. Because all the ones up to this point, write a function g, write a function h for this here. Yes? Give me a letter. Any letter. Z and h, we'll use those too. So we'll use h for this one. We'll use z for the next one. You don't have to write that one down yet. We'll write it down in a bit. Because really, h of x, z of x, we just need a name for it. That's all it is. H of x, z of x, g of x, it's just a name to tell us what the new function is. Okay? So if kind of we went to the last one here, because here we really have two functions. We have f of x, yes, and g of x. F of x and g of x are y. That's all they are. So if I told you we had y equals 4x minus 9, and y equals our 4x minus 4, and I'm like, okay, so we're going to plug 4 into our y equals. Do we know which function we're actually talking about? Well, no, I've got multiple equations up here. If I said that we're plugging 4 into g of x, we know that we're talking about this. It gives us a name. It gives us a specific way to reference an equation. That's why it's nice. We give it a name. We give it something that we can refer back to. That's all it is. Now, for this one here, we're going to call it h of x, but we want to translate this function up 5. So the general form is f of x plus k. So on that note, really what we're saying, f of x, we're taking this function and moving it up by this amount. That's all it is. So do we have to use f of x each time for this here, f of x plus k? Because f of x is just referring to the function f of x, yes? So if I wanted to apply it to g of x, we would use g of x plus k. F of x is just a name. It's not set in stone that it has to be this. Because when we look at this here, we're moving it up 5 units. So the value of k is 5. The f of x, that's telling me I'm referring to this function here, and it's equal to the x. So like I just said a minute ago, if we had said g of x plus k, when I look at the g of x part, we'd find the function g of x and associate it with it. Now we need to start simplifying. Our 3x, is there anything in front of it? Nope, so there's nothing to multiply, nothing to do with it. We just simplify those parentheses and give us 3x. How about the 5? It's just plus 5, yes? 3x and 5, are they like terms? Anything that we can do with it from here? That's it. All we can do to it. H of x equals 3x plus 5. Questions on this here? Yes, sir. If the variables are the exact same, or the variable expressions. So the 3 has that x, 5 does not. So they're not like terms.
Oh, okay, I see now.
After this next one, depending on where we're at, I can show you kind of somewhat of a proof of like terms or how they work. Second one, the next one, f of x equals the absolute value of x minus 3. So the general form for our left-right movement, f of x minus h. What is the value of h? It'd be 4. Would it be positive 4 or negative 4? Positive, because we're moving to the right. Moving to the right, but it ends up giving us x minus 4. Even though h is positive, it does look negative. Just like the last few, we've got to plug x minus 4 into f of x. We've got to replace every x with x minus 4. So we have the absolute value of x minus 4 minus 3. Question? Yeah. Here.
I was just wondering where the absolute value came
Yeah, from f of x. So yeah, they gave it to us in the function. Yeah, if you notice something like that, always ask. 99% of the time, easy to point out. The other 1% of the time is I wrote it wrong. It happens from time to time. Questions on how we got here? Now we need to do some simplifying. Is there any number between the absolute value bar and that parenthesis? No number, no sign, so nothing to distribute through those parentheses. So we still have the absolute value bar. We drop the parentheses, giving us the absolute value of x minus 4 minus 3. Now it feels at this point we have like terms. We have that negative 4 and negative 3, yes? We cannot move that negative 3 into the absolute value. We cannot move that negative 4 out of the absolute value. Because the absolute value is the distance from 0 positive, so we have to take whatever that quantity is first, absolute value of it, and then subtract 3. So we can't move in, we can't move it out. That works with multiplying by an absolute value too. If we'd multiplied it by 2, the 2 would stay out front, it would not go into it. So, this is the final expression, our final equation. Questions on this here? Questions on any of this so far? Okay. We got to about as far as I wanted to, especially with some of the other classes. I don't know if y'all have seen, because a lot of stuff with like terms, or if we said 3x plus 4x, this is technically like terms. Because they both have x, they're both like terms, and we're good there. Greatest common factor. Because we can factor stuff out that's in common with two or more things, yes? Both of these have x in common, yes? So technically, I can factor it out of this here. I can divide it out of both terms. If we divide the x out of the 3, we're left with 3. Because we factor it out, it goes from 3x to just 3. X is out front. Plus, if I factor the x away from 4x, we're left with 4. 3 plus 4 is 7. So we have x times 7. What is x times 7? That's a way to just show like terms, because we can really pull that term out that's in common. 3 and 4, we add the numbers. Because they're the exact same, we can do that, everything's fine. If it was, say, xy, well, I could do the same thing. We could factor that 3 out, or the x out, it would give us 3 plus 4y, 3 and 4y. We can't just add 3 and 4y, because that y is there, it's making it different. So they are not like terms. They have to be the exact same. So if we wanted to be able to do this, we would need 3xy. We would need those terms to be the same. Does that make more sense? Yeah. We'll stop here for today. I know we have a good bit of time. We will continue.